Indirect proof and inequalities in one triangle. This is a new vocabulary word. Proving a statement true by contradiction by first assuming that the desired conclusion is false and then showing that the assumption leads to a logical impossibility. It's also known as proof by contradiction. Now, you may hear this statement again. Proof by contradiction. Pause the video and read the 3 steps. A real-life example of proof of contradiction, or an indirect proof, is that you've accused me of taking your lunch out of the shared refrigerator at work on April 9th. Let's temporarily assume that I did take your lunch. Then I would have to have been at work on April 9th. However, I have airline and hotel receipts showing that I left for an out-of-state trip on April 6th and returned on April 11th. Because I have other proof, you can now say that I was not the person who took your lunch out of the refrigerator on April 9th. On this example, we are told that we are given a triangle ABC. Now, we want to prove that ABC can have at most one obtuse angle. So the very first thing that you do is to assume the opposite. So let's assume that triangle ABC has 2 obtuse angles. Step 2, by definition of an obtuse angle, the measure of angle A is going to be greater than 90 degrees, and the measure of angle B is going to be greater than 90 degrees. By the triangle Sum Theorem, the measure of angle A plus measure of angle B plus the measure of angle C is going to equal 180 degrees. Now we're going to substitute the smallest whole number value for angle A and angle B, which is 91 degrees. So we'll take and substitute 91 degrees in for A and B and add our variable, measure of angle C, and all of that should equal 180 degrees. So let's solve our problem. Now, we find that we end up with the measure of angle C being a negative. However, a triangle cannot have a negative angle measurement. So step 3, the assumption that triangle ABC has 2 obtuse angles must be false. This proves that triangle ABC can have at most 1 obtuse angle. Pause the video and give this one a shot on your own, and then hit play again to check your work. You're asked to write an indirect proof that an odd number is not divisible by 8. So let's look at step 1. Step 1, assume an odd number is divisible by 8. Now we know that even numbers are divisible by 2, so we will label even numbers divisible by 2, or 2 times a number will give you an even number. Odd numbers are 2 times a number plus 1. Let's list that. Now that we have established that an odd number needs to be recognized by 2x and an even number needs to be represented by 2x plus 1, now we can say that our divisible by 8 is represented by 8 times whatever number, because any number multiplied by 8 is also divisible by 8. So let's look at how this plays out. Since we are trying to determine that an even number is divisible by 8, an odd number is divisible by 8, we're going to set 2x plus 1 equal to 8y. So let's move on. We need to divide all of our terms by 8. So we have 2/8x plus 1/8 equals y. However, we can simplify 2/8 to 1/4. So we have 1/4 x plus 1/8 equals y. Now we ask ourselves, what does this mean? When solving for y equals 1/4 x plus 1/8, which is not an integer. The assumption that the odd number is divisible by 8 is false. So, an odd number is not divisible by 8.